Hello, Mr. Sutton here, bringing you the Pre-Cal Honors 7-1 Extra Practice Number 2 solutions on graphing conic sections. On this one, it looks like we're going to be graphing an ellipse based off of the plus here and the equals 1. So let's get the center first. That's going to be 0, negative 1. And now let's get the x and the y radius. X radius, that's the square root of 49 because that's below the x squared. So that's going to be 7 left and right that we're going. And then for the y radius, we've got the square root of 25, which is 5. And I'm definitely going to need to go by 2's on my grid lines to fit all this on here. So I've got my center at 0, negative 1. And then I'm going left 7, right 7. And I'm going, let's see, up 5 and down 5. And then let's just draw the ellipse. On this problem, I'm going to be graphing a hyperbola because I've got the minus and the 1. So let me get my center first. That's going to be 0, 0. My x radius, that's going to be the square root of 25, which is going to be 5. And it's 25 because that's under the x squared. For the y radius, I've got the square root of 9, which is going to be 3. So let me graph my center. And I'll make my grid lines go by 2's just so I can fit everything on here. So we've got 0, 0, and we're going left 5, and right 5, and then up 3, and down 3. Let's draw the box for which those points are the midpoints. Draw the asymptotes through the corners of the box. And now, which way am I going with my hyperbola? Well, I noticed that I have a positive y squared, so that means this is going to be an up-down kind of hyperbola. So I've got a branch up here, and also another branch down here. For this problem, I have a single power variable equals a square root with something squared in it, so that's definitely a semicircle we're graphing. To start this off, we're going to try to turn this into a circle form. I'll do that by squaring both sides to get rid of the square root. So that's x squared equals everything that was inside that square root. And then I'm going to add this y stuff over to the left side. And now I've got something that looks kind of like a circle. So the center, if this were a circle, would be 0, 3. And the radius would be the square root of 49, which would be 7. But now I have to figure out what part of the circle am I actually graphing. Well, since I have x equals a negative square root, the x tells me this is either left or right, and the negative tells me I have the left half of the circle to graph here. So let me graph my center, and I'm going to make these grid lines go by 2's here. So we have a center at 0, 3. And then since my radius is 7, I have to go up to 7 right here. So that actually brings me up to 10. And then I have to go left 7 because they were doing the left half. And then finally down 7. And then just graph that semicircle. For this problem, the minus in here and the 1 is telling me that this is going to be a hyperbola. So let me get my center here. That's going to be 0, 0. And the x radius, that's the square root of whatever's under the x's. That's going to be square root of 4, which is 2. Y radius will be the square root of this 4 here, not that it really makes a difference. Also 2. And then let me get my center. So we got 0, 0. And we're going 2 to the left. 2 to the right, 2 up, 2 down, and this is giving me the midpoints of my box that I'm going to draw now to help me get the asymptotes of this hyperbola. Now to get those asymptotes, we're going through the corners of the box that way and also this other way. And I notice here that I have a positive x squared, so that means that this is going to be a left-right hyperbola. So I've got a branch over here and also over here. On this problem, the plus between these fractions and the 1 tells me that this is going to be an ellipse. So my center, we've got negative 1, 4. And for the x radius, under the x's here, we have the square root of 36, which is 6. For the y radius, we have the square root of 9, which is going to be 3. And I'm probably going to need to go by 2's to fit everything here. So we have a center of negative 1, 4. That's going to be right about here. And we're going left 6, right 6, up 3, down 3, and then drawing the ellipse. For this one, the negative in here and the 1 tells me this is a hyperbola. So let me start with the center. That's going to be a 0 for the x squared there and a 0 for the y squared. The x radius, that's the stuff under the x squared, square rooted. So square root of 25 gives me a left-right value of 5. And then for the y radius, we're square rooting the invisible 1 that's under the y squared. So that's a y radius of 1. So let's do some grid lines of 2's on this one. We have a center of 0, 0. And we're going left 5, right 5, up 1, down 1. And these are the midpoints of the box that's going to help us draw this hyperbola. So now let's draw some asymptotes through the corners of this box. And to figure out which way the branches for this hyperbola are going, I notice that I have a positive y squared up here. So that means we have an up-down hyperbola. So we're drawing a branch up here, and also a branch down here. For this problem, this square root is telling us that we've got a semicircle. So let me start by turning this into something like a circle. Let me square both sides to get rid of that square root. So we've got y squared equals 1 minus x plus 4 quantity squared. And then adding that x plus 4 squared over to the left side gives us the standard circle form. So the center, if this were a circle, would be negative 4 comma 0. Radius would be the square root of this 1, which is just going to be 1. And we're going to go by 2's on our grid lines just to fit it. Actually, no, we don't need to go by 2's. This is such a small radius, we can fit it. So we've got, which side of the circle are we graphing here? Well, we have y equals a negative square root. The y tells us that we're either doing the top or the bottom. The negative tells us we are doing the bottom. So let's go ahead then and graph the center at negative 4 comma 0. That's right about here. And then let's see here. Since we're doing the bottom, we're graphing this part of the circle. So we're doing left 1, down 1, right 1, and connect the dots to get that semicircle. On this problem, we have something squared plus something squared equals something that's not 1. I guess it could be 1, but it's not. This is definitely going to be a circle. So let's get our center. We have 2 comma negative 4. Radius is the square root of this number over here, so that's going to be 3. And we're going to have to go by 2's for the grid lines, otherwise we won't be able to fit everything. So let's graph our center first, 2 comma negative 4. That's going to be right about here. And we're going 3 in every direction now. So up 3, right 3, down 3, and left 3. And then just connect those dots. There's our circle. On this problem, we have the square root of something squared. This is going to be a semicircle. So let me turn this into a circle just to figure out where the center and the radius are. So let me square both sides to start that process. That gives me y squared, and the square root's gone, so we'll just have 9 minus x minus 5 quantity squared. Then let's add the x minus 5 squared over to the left side. And now I have something that looks kind of like a circle. So the center of this would be 5 comma 0. Radius would be the square root of 9, which is 3. And because it is a semicircle, we should figure out which half of this circle we're graphing. If I have y equals a negative square root, that's going to be the bottom half of the circle. So to actually graph this, let me make my grid lines go by 2's so I can fit everything. And my center is going to be 5 comma 0, so that's right here. Since it's the bottom half, I have to go left 3, down 3, and right 3. I'm not going to go up 3 because I'm just doing the bottom half. And then just connect those to get a nice looking semicircle.